So I'm just going to explain quickly why we have the following inclusion: a subset of whole of a omega. Okay. So to explain this, let's introduce some terminology. So for omega, subset of L. So this is a product of fields. Just say J is equal to 1 up to R, Lj. We define, so we note that whole of omega is, so we can find the polydisk via these functions here, R1 omega to R omega. Okay, where Ri omega is the maximum absolute value of xi, right, where x1 through xn is an element of omega, like so. Okay, so there's this formula here where you just take the maximum absolute value, maximum in each direction. Okay, so all right, so what can we do with this? So two things we can do. So two things. The first thing is that so if let's say A is equal to, let's say alpha is equal to alpha 1 to alpha r, then here r, so what do we have? So we have r of alpha times omega. So this is going to be this is going to be the absolute value of alpha 1 times r1 of omega. Okay, and then we have the absolute value of alpha r, r omega, omega, like so. All right. The other thing that we can do is that if we have a union from, let's say, I is equal to 1 up to infinity of, let's say, omega I, right, then, so let's just actually do one at a time. So let's get rid of this, Ri. So this is equal to Ri. So each one of these, this is going to be the maximum here of Ri. I guess we could have taken the, well, not really. So maximum R, let's say Rj. Let's do this Rj, so that there are different subscripts. Rj of omega I, right? For and this varies for I greater than or equal to 1. All right, so we have these two things here. All right, so these two formulas are easy. And this allows us to then conclude that if I were going to take a to the n, okay, so we want to do r of a to the n. So now a multiplies on each component. By, psi j a. So A is an element of Km. It acts on each component of L. This is the direct sum of L psi j. So these psi j's are the ones that are the tuple of embeddings that give. Okay. So I guess this is a tuple of embeddings. So I guess psi j m, something like that. So these are tuples of embeddings that give the Chinese remainder theorem. Okay, so we have, what do we have? So Ri a to the n omega. Okay, let's do Rj. So this thing is equal to the maximum of here, Rj a to the n omega, okay, n greater than or equal to 1. And this so for absolute value of a less than or equal to 1, so this is equal to absolute value of a rj omega. Hence, so this implies that rj a to the n omega. So this is less than or equal to rj a omega, right? And so this tells us that the whole of a to the n omega is contained in the whole of a omega, and that's it.